Good morning. Thank you. So yeah, let's hop right into it, as I want to do by going back into the past here, and look at a little bit of a history of the way we designed internet-facing applications. So for those of you who are too young to remember the last bubble, this was back in scalability back in the day. Scalability when it was pets.com and Cosmo instead of Uber and whatever other unicorn you want to name. No offense to those of you who work for those fine unicorns, of course. So back in the day, we had three-tier architectures, service-oriented architectures, model-viewed controller. We had a lot of names for this thing. But the basic idea was that we had three tiers to our internet-facing apps. You had this view tier in the front. You had your model tier, your database in the back. You had your controller in the middle. And it all was good. It was fine. And then in the mid-2000s, we saw the rise of Ajax. Remember Ajax? Right? That's kind of one of those terms that kind of came and went. I feel bad for the Ajax conferences. Ajax being what might be the worst acronym in human history. So those of you who remember, Ajax stands for Asynchronous JavaScript and XML. Now, this is, on the one hand, totally nonsensical. I mean, what is asynchronous? JavaScript already is asynchronous. Like, what does XML have to do with any of this stuff? But also, you can't have one of the letters of an abbreviation stand for a conjunction and one stand for an abbreviation. I mean, if there are capital crimes for acronym formation, Ajax has definitely committed them. REST, only slightly better. REST is representational state transfer. It's like, wait a minute, I didn't hear anything what does E stand for? It's like, oh, E is the second letter in representational, I guess? Again, it's like, come on! What the hell is an acronym anyway? But the Ajax and REST revolution that was kind of spawned by this gave rise to these true web applications. The browser was actually serious. We could go build some interesting things. And this led to some broader architectural questioning that a lot of us went through now 10 years ago. One is, why am I restricting HTTP for the web? HTTP is a kind of a useful protocol. It's very nice to be able to see what's happening and so on. Why am I only using this for the web? Can I use it? Can I build an internal system out of HTTP? And why is REST restricted to web apps? Why am I only using REST for the stuff that's web-facing? Can I build a distributed system? I mean, it's kind of ironic that for all of the literature on distributed systems and so on, it was the web that actually allowed us to truly understand distributed systems or gave rise to a much broader adoption of distributed systems inside of the walls of a service. And these two things also led to actually an even bigger question. In this service-oriented architecture, I've got these big monoliths. Well, instead of having these monoliths, should I have smaller things that I'm going to talk to and have more of them? Break the monolith up into smaller parts that I can more easily understand, and that I can more easily update and so on. It's like, that sounds vaguely familiar. It's like, yes, that's the Unix philosophy. If there is a Talmud for systems design and implementation, it is the Unix philosophy, as originally articulated by Doug McIlroy. Doug McIlroy is the father of Unix that you haven't heard of. So Ken Thompson and Dennis Ritchie are the fathers of Unix, but it was really Doug McIlroy that gave Unix its soul, its spirit, its guiding principles. The guiding principles are, one, write programs that do one thing and do it well. Write programs to work together. Write programs that handle text streams. Okay, text streams, a little dated, or HTTP, JSON over HTTP. Because that is a universal interface. Wow, those are very universal concepts. It's a very universal idea. This, I believe, and the older I get, the more strongly I believe it, this is the single most important revolution in system software thinking. You would be wise to wake up every day with a daily affirmation for the Unix philosophy. Call your children in. Read the Unix philosophy aloud to your children. Not like they'll understand it. They don't understand anything. But when they're older, they'll get it. The old man was right. He was right. God, the Unix philosophy is that important. Why did I become a monolithic thinker? Just to rebel. So this is very important. Now, when we apply it to HTTP-based services, we have microservices. And microservices strive to do one thing and do it well. And we're going to replace these monoliths with smaller HTTP-facing services. Now, you'd be forgiven if the term microservices made you throw up in your mouth just a little bit, made you just like seize up a tiny bit. And you might have this reaction that Kelly Summers had earlier this year in terms of if I hear the term microservices one more time, I'm going to actually lose my mind. I'm pretty sure that this is like the founder of Surge. I feel like that's actually Theo. If you go back and if we put more hair on that, I think that actually is Theo. So microservices do engender a certain amount of frustration. And I think they engender some frustration because they're viewed as a panacea. Like, oh, we'll just spray microservices on this. And we know that microservices are not a panacea. It's more complicated than that. But they're there. Because microservices are a very good fit for what we're trying to do. And you get modern environments like Node and Go. I mean, it's kind of an open question. Node and Go, did these things rise because we were developing microservices or vice versa? The reality is that the rise of new languages, new ways of thinking about systems is very tied in to the way we think about microservices. And these new languages like Node and Go have attributes that are very useful for developing microservices. They're lightweight. They've got a light memory footprint. It's not like you don't have to start this gigantic Java VM that is taking like a transoceanic flight. I made the mistake actually we had a bug in our system once where we only accepted a 4K of arguments on the command line. And Cassandra didn't start. And you're like, well, that seems strange. Because it was doing a find for everything that ended in jar in this gigantic subdirectory and slapping that onto the command line. And you watch this thing start, it's like, I mean, this is like continental drift. It's just amazing. And then people complain about the startup time. It's like, you complain about startup time. Anyway, maybe you want to get rid of the find. But these new environments are much lighter weight. They're much smaller. We're not going to fly to Hong Kong here with a JVM. We're going to do something much smaller, much less memory impact. We've got first-class asynchrony. We're not going to block the world when we need to block, and so on. And these environments are a perfect expression, or are an expression, of the Unix philosophy, and the whole idea of libraries over frameworks and so on. So the question that we have before us, and that I'm particularly interested in as an infrastructure person, is how do we actually deploy these things? Because microservices are small, right? If your microservice feels like a monolithic service, it's no longer a microservice. The animals are walking upright. So but your microservice should be small. It's tautologically small. And clearly, we're not going to have one physical machine per microservice. I mean, that's obviously ridiculous. We're going to have many of these on a piece of physical hardware, which means that we have to virtualize. We're going to go virtualize somewhere in the stack to be able to run a bunch of different microservices. Where are we going to virtualize? This is a key question. And the answer to that is going to really depend, as so much does in our industry, on economics, where the economics will dictate what we can actually do at what layer of the stack and when. So the first answer is the oldest answer, and that's hardware-level virtualization. Hardware-level virtualization says that in order to virtualize, we'll give each of these microservices, each app, each tenant, its own virtual hardware, its own virtual CPU, its own virtual DRAM. And this is a very, very old idea. It dates back to the 60s. Now, it's easy to hand wave, it dates back to the 60s, everything dates back to the 60s. But let's get a little more specific about it, because the specific history of hardware virtualization is actually pretty interesting. So back in the 1960s, there were instruction sets everywhere. Everyone had an instruction set. I mean, it was amazing. You had companies like Singer was making a computer. It's like the sewing machine company, the sewing machine company. Bendix was making a computer. Like the brake company, the brake company. Everybody made their own computer. They all had their own instruction sets, and it was chaos, right? And so IBM comes in, and IBM had their own many different instruction sets. They had the IBM 650, the 1401, the 1620, the 7090. And IBM says, we are going to deliver the one instruction set to rule them all, and it shall be named 360. So they developed 360 years late, famously years late. It's like, do I recognize that from, did I read a book? Yes, The Mythical Man Month. You read a book about what a disaster that was. But they developed System 360, and 360 so-called for 360 degrees of view. And 360 was beautiful, righteous hardware. So of course, you would rewrite your software for it. And actually, as it turns out, and this is kind of surprising, because I mean, this is like 1965. Even by 1965, software has so much inertia that people don't feel like rewriting their software for new hardware. Actually, the software has actually got greater inertia, greater mass than the hardware. It's kind of amazing. So people don't feel like rewriting this stuff. And in particular, the IBM 1401 was the most widely used instruction set. People didn't feel like rewriting it. So we kind of stuck, because IBM was not interested. IBM wanted to get people to port their apps, and we were kind of stuck in that mode. And then into this came Honeywell. It's like, wait a minute, the thermostat people? The thermostat people. Remember, everybody's making a computer. It's just Joker's wild, right? It's a great time to be alive, I guess. So Honeywell, the thermostat people, are making a machine, the H200. And it's a transistorized machine. And Honeywell has this genius idea. Let's make an H200 look like a 1401. We will write software that makes the H200 look exactly like a 1401. And indeed, they did, because it wasn't complicated. The model wasn't that complicated. And now they could run 1401 apps much faster than the non-transistorized 1401. And I love the name for the software. They called it the Liberator. I mean, does that make you miss the Cold War or what? You know? It's like, if it's not going to be like hardware virtualization software, it's going to be an ICBM called the Liberator. Anyway, so we had the Liberator. Liberator. I think you have to say it like that, by the way, whenever you say the Liberator. So the Liberator did indeed liberate all the software, takes off, IBM sees this, and IBM begins to, it adds 1401 emulation to the 360, then of course puts the thermostat out of business with respect to the computing company. But it thrived ever since. Hardware virtualization has thrived ever since. And actually, kind of an interesting footnote to that story, I was visiting with a CIO on Wall Street right after Y2K, and we were talking about Y2K problems. For those of you who don't remember Y2K, don't worry about it. The adults got very upset if you were a child at the time, and nothing really happened. And actually, ironically, at Sun, I was at Sun at the time, a third of our Y2K problems had nothing to do with the digits in the year. They were leap year problems. So there was another Y2K problem that I don't know if others had this problem or not. Presumably they did. So the year 2000, like leap year problem, but every 4 years is a leap year. Yes, that's true. Every 4 years is a leap year, except every 100, except every 400. And there's an amazing amount of software that somehow managed to encode rules 1 and 2, but without rule 3. It's like, how do you get to the point that you're doing every 100 and not seeing that it's every 400 is a leap year? So 2000 was a leap year. So if your software was stupid or smart, it was fine. If it was too smart for its own good, it was not fine, and we had an amazing number of problems that were due to just that problem. Anyway, I digress. So we're talking about Y2K. Needless to say, his Y2K problems, he was not terribly interested in my leap year stories. Like, not interesting. Our Y2K problems, 45% of them came from a single platform. I'm like, what was that? The IBM 1401. In 2000. This is a machine that was old for my father. I'm not 12. I know I look 12, and I don't know when I can grow a beard, but it doesn't look like it's going to happen anytime soon. But I may be prepubescent, but I'm the world's oldest prepubescent man, essentially. I'm old, my father's extremely old, and the 1401 is older still. So the fact that we've got software predating from that era that's now running production, oh my God, hardware virtualization for the win. Wow. And if you want to run 1401 software to the heat death of the universe, hardware virtualization is your ticket. It's great. You're abstracting at that lowest layer of the stack. It's unbelievable. But it cuts against you in almost every other way. Because you're at that lowest layer of the stack, what the hypervisor is making available, because that's what we call that operating system at the bottom, what the hypervisor is making available are very low-level primitives. DRAM, for example. It has to give DRAM to a guest operating system. You have to run a guest operating system. You have one operating system that, again, we call the hypervisor. You took another operating system on top of it called the guest operating system, and then your app goes up here. It's like, does the guest make it faster? No, no, no. No, two operating systems are never faster than one, I'm afraid. It just makes everything slower because the guest operating system is being lied to. That's our euphemism for virtualization, by the way, pathological lying. We're lying to this guest operating system. And so when it wants to do I/O, it does I/O to the hardware that actually traps in the hypervisor. It's like, whoa, 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 this guy wants to do I/O. OK, we got to make the lie look good and actually do the I/O. And then, meanwhile, you're at the application layer being like, God, this thing is slow. It's, of course it's slow. Do you have any idea what had to happen? It worked, didn't it? I mean, that's amazing that it worked. But your I/O is slow. You're like, OK, wow, that sounds awful to be so far away, to be at such a high layer of abstraction, to have my app be lied to so much. Again, cuts against tendency, because when you consume a gig of DRAM, we don't know if you're actually consuming that gig of DRAM or not. We have to just give it to you. When you want to do I/O, it's very painful and so on. OK, but God, who would do this? Well, everybody, as it turns out. Because that's what you do. When you're running on Amazon, that's what you're doing. You're spinning up virtual hardware. You're spinning up a pair of virtualized hardware running Xen, you're running VMware, you're spinning up virtual hardware that way. We are running virtual hardware nearly everywhere. And it's great because it can run legacy stacks unmodified, but it's really bad for everything else, and it's especially bad for microservices because overhead really dominates. So what about platform-level virtualization? Hardware-level virtualization is at the bottom of the stack. Let's go up to the top of the stack and virtualize the platform. And now what we're going to make available to the developer are these really happy abstractions, developer-friendly abstractions. I kind of hate the term developer-friendly. I mean, I am a software engineer, so I should like that, but developer-friendly just feels like a coloring book to me. You know, I don't know, I've got that kind of natural. How about engineer-friendly instead of developer-friendly? But so you have these developer-friendly abstractions, and indeed, they are friendly. It's like candy. It's delicious. It makes it really easy to go build your app at this highest layer of the stack, but then the thing doesn't scale. Wah, wah. Because when it doesn't scale, you're incarcerated now by all of these abstractions. You're in a straitjacket of abstraction. This is the Google App Engine problem. Google App Engine, absolutely awesome to build toys. Really not so good for actually building industrial strength infrastructure. So platforms as a service are great, platform level virtualization is great, but it's too high for much of the stuff that we want to go do. Okay, so what about OS level virtualization? Let's go, if hardware level virtualization is too low and platform level virtualization is too high, let's virtualize in the OS. And indeed, that's an excellent idea. And OS level virtualization, creating a virtualized OS, actually dates back to the 80s with the rise of Chroot. So Chroot, those of you know what Chroot is, Chroot allows you to virtualize the file system and say, I would like this directory to be my new root. It's actually an important development in the history of computing, and it's one that we've got not so much insight into why it was done. So this is the closest we can come to is a recollection from Kirk McCusick to Paul Henning-Kamp and Robert Watson. This is a citation in their FreeBSD jails paper that according to the SCCS logs, the Chroot call was added by Bill Joyent on March 18, 1982, approximately a year and a half before 4.2BSD was released. Nobody knows why. And you know, it was Berkeley, it was the early 80s. You know, you'd have to look at the timestamp of when this was pushed, but God only knows what people were on at the time. So for whatever reason, Chroot comes to Bill Joy in some acid-induced hallucination. It's like, I should do what the leprechaun is suggesting, yes. And the leprechaun was right. This is a great idea, and presumably to allow Bill Joy to build 4.2BSD on an older system. But we actually don't know why. Anyway, we have Chroot. Chroot's great, and the leprechaun was right. But as it turns out, the leprechaun is just an acid-induced hallucination, is not actually going to have you build industrial strength infrastructure. And Chroot, like so many things that feel elegant on a weekend, like, oh, I could just do this in a weekend, which you often can, but it's often the wrong thing to do for the long term. I mean, the difference between elegance and disaster is really just missing the runway. And Chroot almost sticks it, but then kind of doesn't. Things like CD dot, what about CD dot dot? From a Chrooted environment, like, oh, yes. What if you CD dot dot? Well, you could break out of your Chrooted environment. So these things were not necessarily all that great for security, and these can be patched and so on, but FreeBSD actually picked up the mantle from there and said, let's actually take this containment mechanism and make it bulletproof and secure with jails. The name tells you all you need to know. It's a jail. I guess they stopped short of calling it a prison. I guess prison would just feel a little too real for, like, you know, where recidivist applications get shivved in the shower. So it's a jail. Jail feels happy. It's like, oh, it's like Wild Westy, spaghetti western, kind of like break out of jail. Jail's fun. Okay, so anyway, it's a jail. But we're going to confine the application. The whole idea here is we're going to virtualize the operating system not to solve a microservice problem that lies 2 decades in the future, but to actually confine an app. Really so I can take untrusted software and execute it. Postfix being kind of the canonical example. There are many, but I want to take something that is untrusted, I want to execute it, and if it melts my machine, it can't because it's in jail. It's in a jail. Okay, this was great. This was powerful. And this was done in the late 90s, and it inspired us at Sun. So I worked at Sun for 14 years prior to coming to Joyent, and it inspired us at Sun to take this to its logical conclusion with zones. And if you take one thing out of this presentation, hopefully it won't be the 1401 or the leap year issues. If you take one thing out of this, I would really recommend you read this document from 2002 This is the actual architectural document that describes zones, and it feels amazingly prescient and modern in terms of why we built containers at Sun. In fact, open question, who coined the term containers? I believe strongly it was at Sun. I'm not certain of this. I unbelievably, and it kills me to say this, I think it may have been someone in Sun marketing who actually coined the term, and I'm almost certain we made fun of it at the time. It's like containers, it's a zone, not a container. And now, of course, I just presented at Container Summit, so like obviously joke's on me. But this idea of actually, let's not just contain, do that, yes, but not just contain. Let's actually use this as a way of virtualizing workloads so we can sell you a larger computer. But we kind of left that unsaid. It was really so we could sell you a larger computer that kind of time had forgotten. But let's leave that aside for the moment. This is what the software allowed you to do, is create a virtual operating system, a zone, in which you can run an app. And now this is much, much, much more lightweight. So OS level virtualization, you've got a single operating system kernel. I'm going to create a virtual operating system. And now all of my resources are properly shared with the rest of the system. When you ask for a gig of DRAM for this virtual instance, we don't have to give you a gig of DRAM. We can just make a note to ourselves, like not to exceed a gig of DRAM. And if you don't use that gig of DRAM, it can be used by someone else. When you need to do I/O, you just do I/O. You just do a read or a write and so on, and you trap into a single operating system that actually talks to the hardware. It's a huge performance win. It's a huge tenancy win. It's a huge win across the board, especially when you're developing microservices, small things. It just makes total sense. And we at Joyent have known this for too long. We have been in the right place for the wrong time for a long, long time. So the formation of the company was really around containers. Joyent was originally running FreeBSD jails. When Solaris was open sourced, with Open Solaris, Joyent lunged, was the first company to run ZFS in production, first company to run zones in production, because Joyent saw the value of OS-based virtualization in terms of efficiency and tenancy and so on. But we were a very lonely voice for a long time. And actually, we did this so long ago, this is in 2006, we've been running these in production. We've been running containers in production for so long that we actually implemented hardware-based virtualization. So in 2011, Robert Mustaki and Max Bryan and I went and ported KVM to SmartOS so we could actually run hardware-based virtualization and run Linux guests and Windows guests and so on. And like an engineer assigned to build a sausage factory, I came out an ardent vegetarian. Like, I will not touch that stuff. I don't care how delicious it is, because I've seen how many raccoons fall into the hardware virtualization sausage. And so if you're wondering where that tang comes from, that's vermin, OK? You don't even want to know. If you're lucky, it's vermin. If you're unlucky, it's Bob. Bob's been missing for a while. We don't know what happened to Bob. So I came out of that experience believing much more strongly in OS-based virtualization. And it's very strange to know that OS-based virtualization absolutely is the future, but boy, no one else seems to believe that. I guess we're crazy, which is probably true as well. So we stood by that for a long time, and we were really emphasizing the operational characteristics, performance, elasticity, and tenancy. Meanwhile, others saw some of the value that we saw a little bit differently. What others saw was actually the value to package up a bunch of software and actually deploy that and redeploy that quickly with this containment mechanism. And so they're actually relying less on the containment mechanism, but using this as a vector for a PaaS. So Heroku did this with Cedar, a company that you almost certainly haven't heard of. .cloud did this, and they're a PaaS provider. Platform as a service, terrible business, really, really tough business. There are a handful that make it, a lot that don't. It's a really tough business to be in. And .cloud, like so many of these, realized that actually that we're not making it as a PaaS, but there was a lot of interest in the orchestration framework that they had developed to actually deploy containers. And in 2 minutes into this presentation in 2013, they open sourced it, and it was Docker. And .cloud, when Docker took off, .cloud very quickly changed its name to Docker, and the history was written. So in 2013, Docker was open sourced and took off. And it took off because it connected to a problem that lots of us have. The problem that lots of us have, as much as I believe in the operational efficiency, as much as I believe in the tenancy and the performance and so on, the problem, the more pressing problem that people had is, how do I develop something on my laptop and reliably deploy it into production? Software just got way too complicated. And by the way, open source played a role in this. Right? With open source, it used to be that there were only 3 vendors to talk to, and you just figured out which one was going to molest you the least and went with that. But now it's an all open world. You have so many choices to pick from. Virtually all of the technologies, if not all of the technologies you're hearing about at Surge, are all open source. So in that world, there's so much to pick from. There's so much developers can pick from. How do we actually deploy anything? How do we actually get anything done? And Docker allows us to solve that problem. Containers allow us to solve that problem by allowing developers to think operationally and allowing those that operate software to think in terms of software development. So it is a true realization of this kind of DevOps ethos. So developers can encode deployment procedures via an image. Images can be reliably deployed into production, so you get exactly what you wanted. If you want to roll back, you can roll back to this other image. We're not going to modify these images. They're not going to be mutable. It's a big, big win. Quickly deployed, redeployed, and so on. And it really complements the library ethos of microservices. Docker and microservices are a great fit for one another. Probably not a coincidence. The rise of one almost certainly accelerated the rise of the other. In terms of one way to think of Docker, I've said this before, I will say it again, Docker is doing to apt what apt did to tar, or CPIO. Apt still uses tar and CPIO in the animal brain, but you don't think in terms of CPIO. And God, I love people who complain about tar options because they're just self-identifying as people who have never used CPIO. Tar is like the GUI compared to CPIO. It is the point-and-click CPIO. Anyway, when you get to that higher level of abstraction, you can do more. And now we're getting above apt with Docker, and we've generated what Roman Shapachnik of Pivotal has famously called 21st century ELF. We are generating now these effectively static binaries that are an image that developers developing on their laptop or what have you, and we're going to deploy that into production and get out of some of these problems we've had in terms of dependency hell and upgrades and so on. So I think the Docker revolution is very, very real. And the Docker model and the take-up of that has pointed to the future of containers. And the Docker challenges now are largely operational. Network virtualization, persistence, security, and so on. To those of us who've been deploying containers in production for a long time, people say, well, God, I love containers, but they just can't be made secure in production. You're just like, no. We've been doing this for so long. I understand why you think that, because you're conflating containers with Docker, and you're conflating containers with the Linux implementation of containers. And I'll correct myself, whenever you refer to containers in Linux, you must put air quotes around it, because they are containers. Containers are actually an upstack notion in the Linux kernel. The Linux kernel actually only knows about namespaces and cgroups. And containers are a fiction that user-level software tries to put on top of it. And as a result, it was not born secure. Security was not the constraint for Linux containers. They were not born secure, and what we have now, unfortunately, is a world in which people love Docker, but now we're trying to figure out how to run it securely, and it's like, well, yeah, I can't run it secure, containers aren't secure, so I guess the only thing to do, for multi-tenancy and so on, I'm actually just going to deploy my Docker containers in a hardware virtual machine, in a VM. No! God is so upset. Come on, humans. I try to allow you to have these advances, and must you do this? Must you take the operational advantages of containers and now shackle them to the 1401? Please don't do this. Please don't do this. And when you deploy containers via a VM, you negate the economic advantage of containers. So how do we do this? How can we get to production with Docker? If VMs are a vestigial representation that we want to actually get to run containers on the metal, how do we run Docker containers on the metal? Meanwhile, over here in SmartOS, we run containers on the metal, have been doing it for a long time. How can we actually make these two worlds meet? And this is the problem we put in front of ourselves a year and a half ago, a little longer, almost 2 years ago. How can we combine the Docker model with the proven production of SmartOS? And that would give us the best of all worlds, right? We would get the agility of Docker, production-proven security, on-the-metal performance. It's a win. Sounds great. Let's do it. Well, there's a little obstacle. This little binary issue, as it turns out. So Docker containers, when you deploy a Docker container, it's a Linux binary. These are Linux binaries that we're moving back and forth. And yeah, we're not actually Linux. We're Unix, but we're not Linux. We're an Illumos derivative. Illumos is the open source, inherits the open source heritage of Open Solaris. Oracle invented a new word when they reproprietarized an otherwise open system. They took open source closed. I won't go into that in detail. But yeah, exactly. Those of you who are just about ready to check your bingo cards, put your pencils down, because I'm leaving Oracle alone. It's like, damn it, I was going to get bingo. We've got, unfortunately, we have a different binary substrate. And to ask the question, like, well, why is it different, is to replay the Unix wars from a long, long time ago. Now, fortunately, Linux itself is actually just a kernel. And ironically, this is a major point of disagreement that I have with Torvalds historically, is I believe that an operating system is more than just the operating system kernel. It's the OS kernel, plus the system libraries, plus system commands, and so on. FreeBSD shares that belief, by the way. Linux believes, Torvalds believes ardently, that the operating system stops at the kernel boundary. And like glibc, like that's just some software you run, man. That's not Linux. That's something different. And indeed, there's actually, you can run alternative libcs. I mean, if you really want to get off the beaten track, there's an alternative libcs. They're actually pretty cool. It's something called Muscle. It's pretty neat out there. But you can get alternative libcs. And now the Linux just being a kernel, on the one hand, I disagree with it. On the other hand, helps us a great deal. Because if Linux is just a kernel, that means that you can have a kernel that implements a Linux system call table, and you're done. You can actually convincingly lie/virtualize the Linux environment. You can convince the application stack that this is Linux. And this is what we did. We spent a long time doing it. The technical details are beyond the scope of the presentation. My lightning talk, I guarantee you, I haven't even picked which little epicenter of rage I'm going to hone in on for my lightning talk. Implementing the Linux system call table for SmartOS has given me 10,000 years of lightning talks. So I could go for a long, long time. I actually don't know which one I pick. I may just have an aneurysm on stage, actually. It's entirely possible. So we got this working. I mean, this is a tweet now a long time ago. It was a year ago. Of XFCE, I guess that's a thing. Firefox, Skype, running on Ubuntu 14.04 directly on SmartOS, running dtrace alongside it, getting all the SmartOS advantages. And we think, like, wow, I think this is going to be a pretty big deal for people, because I think we thought that others saw what we saw, which is, boy, I want to have my binary ecosystem for Linux, which, let's face it, is a euphemism for being able to Google your problem. I get it. You want to be able to Google a stack trace. There's nothing wrong with that. Just like own it. It's fine. It's totally cool. Like if you have a stack trace, you just, like, I don't want to be the first person to do this. I know, it's cool. You don't have to whisper it. It's fine. It's like, that's not wrong. You don't have to act like you're a bum because you want to be able to take your stack trace, run into Google, and have Google fix your code for you. I mean, it's like, maybe a little bit of a bump. Okay, whisper it a little. Just whisper it a little. But no, it makes sense. People want to be able to do this. We thought it was going to be a big deal to be able to get that operational efficiency of SmartOS. And sure enough, this is the reaction to that particular tweet. This is one of those things. Unfortunately, my kids are old enough to be on the internet now, the kids are starting to watch my own presentations. I'm a little bit terrified that they're going to see this particular slide, because I've got an 11-year-old, an 8-year-old, and a 3-year-old, and they are simply waiting for the word shitballs to show up in their collective ecosystem. It simply hasn't happened yet. The future has not yet unfolded. Getting shitballs in my house is going to be like getting bed bugs. It's never going to come out. So please don't tell my kids this. Another much more recent tweet, because we've been running this in production for a while. Ryan Zazeski was actually at Illumos Day yesterday. SmartOS Augmented Zones, 9 out of 10 Linux users don't realize it's actually Illumos. It's very convincing. It looks, feels, and smells like Linux. To which Bryan Horstman-Allen, who's been at Surge many times, I think he's at Surge this year. But the last one is probably using Haskell, which I think is funny. I'm not even sure why. I don't even know who that's offending, but I just think it's funny. With Haskell, I used to think that no software was written in Haskell. One of the things that's been fun about doing Expanded Zones is one of the things we do when everything is just working is we just go on to Hacker News, see what the latest thing is, download it, run it, and see if it works. And there's a thing called Elm. You're like, oh yeah, Elm, the mail reader. No. You've also self-identified as being old, and you will follow me into that doorway. We are now so old that the children are ignorant of mail readers like Elm, and they're naming their language Elm. So there's a language called Elm. You're like, okay. And you look at it, you're like, this is kind of spacey, but all right, fine. So you download that thing. Turns out Elm is a veneer on Haskell. And Haskell, I start installing this thing. I start following the install instructions of this thing. Haskell starts downloading the internet, as far as I can tell. And downloads 6,000 packages. And I'm like, okay, old conventional wisdom, nothing written in Haskell. New conventional wisdom, way too much written in Haskell. What the hell is this? And then it complains about a dependency conflict deep into two modules that are literally like, n,000 nodes deep. and there's a dependency conflict. And from our perspective, as the ones like running the L-expanded zones, you're thinking, oh God, if this is a bug in our software, God help us. And it's only showing, turns out you just Google this thing, of course I did the same thing, you Google this error message, and it's like, oh yeah, I'm in Cabal hell. That's a thing. So if you Google Cabal, Google will suggest, do you mean hell? And it's like, I actually did, yes. So Haskell, beautiful language, hideous everything else. It's like the people of fastidious mind who live disastrous lives, you know? I think Haskell's the same way. It's like, you're on your 8th wife? Wow, Jesus. Anyway, so we got all that stuff working very convincingly. And so now we've got Linux working on SmartOS. We've got it working, arbitrary Linux apps running in a SmartOS zone. How do we go to provision this thing? This is the next challenge. How do we go provision it? And the way you do that historically with Docker is you got the Docker engine. The Docker engine actually provisions these things. Docker engine is written in Go. But for us, because we're eliminating the VM, this is running directly on the metal, the way you provision something in a cloud, because Joyent, we have our own public cloud, the way you provision something in the cloud is you are on the control plane of a cloud. If you can provision something, you can also deprovision something. And we're not going to take software off the internet and download it into the control plane for our cloud. We're just not doing it that way. And so we're not going to take the Docker engine, nothing against the Docker folks, we're not going to take the Docker engine and actually run that in the control plane. So how are we going to do this? And we looked at, like, can we modify the Docker program itself? And it's got tons of Go and Linuxisms that are their own 10,000 years of lightning talks that we won't go into. It's like, how can we go do this? And fortunately, we made a discovery that actually harkens back to some very old engineering. Anyone know this guy? So if you're, as an American, you're totally excused for not knowing this guy. Of course, as an American, you're also not excused for not knowing the capital of Canada or even that Canada is a country. This guy's not Canadian. He's actually English. If you're English, you should know this guy. He's on your money. This is George Stephenson. George Stephenson is a big old Victorian stud who built basically railroads. So he was the railroad engineer. And George Stephenson very early on realized that in order for railroads to succeed, we had to have a standard gauge. And he developed what became still the standard gauge. I believe it's number 2 on there. And if there were a Victorian era Hacker News, it would be arguing about these various gauges. The 1/8 of an inch makes a total difference. Like, you can't run that one. It's like, okay, these are the same thing, right? Can't we just Google our stack traces and go with, like, number 2? But so George Stephenson realized the power of having an interface and realized that they needed to actually standardize with standard gauge, and railroads took off. Actually, an interesting story that I cannot help myself from sharing with you. So the first railroad that was really built was in 1830, going from Liverpool to Manchester. And so George Stephenson builds this thing. It's got all sorts of technical advances in it. It's got double tracking. It's very fancy. It's steam-powered, of course, first steam-powered railroad. Okay, so they're going to have, everybody's going to come out for this. And they've got the Duke of Wellington comes out. Everyone's out to watch this. And they get everyone loaded on the train, and which is like, that's a bad idea, bad idea. Like, if I'm doing a demo of technology for the first time, I don't take the Duke of Wellington and be like, well, now let's put the Duke of Wellington in production. It's like, nah, let's not do that. Pick the intern. So they take everybody, and they start going off to Liverpool, and quickly one of the trains derails and is rear-ended by another train. Like, oh my God, demo over. Well, it's the Victorian era, so we actually just pick up the train, put it back on the tracks, and we're all good. Like, okay, fine. So no, the demo must go on. All right, so they keep on going. And at one point, one of the trains stops, and a distinguished member of Parliament who was in a giant fight with the Duke of Wellington really wanted to make up with the Duke of Wellington. So he got out to go try to make amends to the Duke of Wellington. And he is doing what you should never do on a double-track rail system. He was standing on one of the rails talking to a train on the first, and the other train came and just wrecks this guy. The end. Dead. Dead man. Okay, wow. Demo over. No. Not so fast. We have to go to Liverpool, where there is an unruly mob, or Manchester, I think it was going to Liverpool to Manchester. There's an unruly mob in Manchester that demands we arrive. That's not going to work well. So they get to Manchester, everyone's angry, they're pelting it, they go back. It's a disaster, total disaster. They have a state funeral for this guy. They write the obituary for the state funeral for the member of Parliament. They write the obituary for him, and everyone's reading this obituary, and they're like, wait a minute. There's a railway from Liverpool to Manchester? That's awesome. So sometimes, actually, throwing out a dead member of Parliament may be great for demo day. I don't know. So anyway, the railways took off much later, actually. If you know this guy, you've been hanging around containers way too long. So this is a guy named Keith Tantlinger. Keith Tantlinger developed the greatest thing you've never heard of, the twist lock. The twist lock is what allows for intermodal transportation. The twist lock is what actually allows containers to be stacked on one another, what allows one container to be locked on to another. And very, very far-sighted individual, this is in the 50s, he insisted on patenting this in such a way that it could be licensed to everybody. So they deliberately wanted to license it in perpetuity to all their competitors to allow this thing to take off, because he saw what George Stephenson saw, which is the power of an interface. That if we can all agree on an interface, great things can happen, innovation can happen. And we actually have that in Docker, fortunately. Because Docker is, and one of the if you're new to Docker, how many of you use Docker, by the way? Okay, a decent number of you do, a decent number of you don't. Those that do have already felt this pain. Those that won't will at some point. It's like, I'm looking for the Docker daemon. Where's the Docker daemon? I downloaded the Docker client. Where's the Docker daemon? Well, funny story, it's the same program. There's one program, Docker, that can run either as a client or as a daemon. And fortunately, connecting those two is actually a very well-defined API. That heritage from George Stephenson and Keith Tantlinger, we've got a very good API between the two. So clearly what we needed to go do was implement a Docker remote API for Smart Data Center. Just a quick aside on Smart Data Center. Smart Data Center is the software that we built to orchestrate our public cloud at Joyent. We historically and still have sold that to people who want to run their own clouds. And it was born proprietary, but just over a year ago, or just under a year ago, coming up on its 1-year anniversary, we open sourced SDC. So all of SDC is open source. So this is now all open source, and everything we're talking about is open source. And SDC is, just to be clear about SDC, Smart Data Center is actually designed to get shit done and actually operate an actual cloud. It's not designed to run arbitrary hypervisors. We're not trying to sell legacy hardware. We're not trying to sell you a SAN. We're not trying to sell you blades. We're not trying to get 600 companies to agree on anything. Yes, that is the number of companies that are in the OpenStack Foundation, 600 companies. The last time 600 companies agreed on something that had a positive outcome was World War II. You can't get one company to agree on anything, let alone 600. SDC is designed to be really quite opinionated, leverage the strength of SmartOS, CFS, dtrace, zones, crossbow, and so on. So it runs both the joint public cloud and people run it on-prem as well. And the requisite architecture diagram there. It's very microservice-based. Although we didn't call it microservice-based, we called it, we've got to burn this Ruby shit to the ground-based. We had a Ruby monolith that had got, I really should not decry Java for being a monolith, because at least Java is like a maintainable monolith. When Ruby goes monolith on you, you are in such a world of hurt, especially when ORM is involved. It was bad, bad, bad. And so we got rid of that thing. Again, we didn't call it microservice-based, but it is microservice-based. That's effectively what it is. So Triton is what we launched earlier in the year. Triton, again, all open source, and it combines SmartOS and Smart Data Center and this Docker remote API endpoint. And the key is that with Docker traditionally, you run a Docker host, which is a VM, angering God, running a Docker engine. And if you want to run more containers than fit on a VM, you have to run many VMs. It's like, oh, don't worry, we can orchestrate that. It's like, no, I am worried, because you've got this extra layer of abstraction. Triton dispenses with the VM abstraction entirely. What you allocate are containers. When you do a Docker PS, you see your containers across the entire data center, regardless of which physical machine they happen to have landed on. So you don't have to connect to a particular Docker host. You are connecting to a virtual Docker host. And of course, you get the added benefits of, by the way, it performs like a bandit. It's got great tenancy and so on. But what we have found with Triton, and what people have found, so we deployed this went into production in June. We first launched it in March. What we have found, actually, is that what people really, really, really like about this is eliminating the VM from a mental tax perspective. You know, we talk about scalability at Surge a lot. Mental scalability is also very important. And getting rid of the VMs allows you to mentally scale and see all of your containers. You don't have to see VMs that then contain containers. And it allows you to transition, as one of our customers told me, it's allowing us to transition from an allocation-oriented mindset with VMs to a consumption-oriented mindset. So again, you can go play around with that. If I got a little bit of time at the end here, I'll give you an actual demo, because it has to kind of be seen to be believed. So all right, so we put Joyent in production, and what have we learned from that? You know, we got to talk disaster porn here at Surge. What have we actually learned? And one of the things that we have learned is, by virtualizing the Docker host, Docker anti-patterns have revealed themselves. So of those of you who've played with Docker, how many of you are running Docker in production today? Oh, wow. Okay, wow, did the audio just go out? Wow, that's amazing. Well, okay, that's great. I mean, good on you. I can totally understand why. Because wow, I was actually not, sorry, I'm caught a little bit flat-footed. I was actually expecting that number to be like low, not 0. So then I can't say, like, look at these, at least these people have figured it out. And the challenge of it is that Docker engines have lived in VMs since their beginning, because there is somewhat of an ignorance of the fact that containers can live on the metal, and these abstractions have leaked. And now we have a notion of a Docker container being in a VM, and we do things where we go to that host VM to manipulate the Docker container. Even worse, we allow the Docker container to get back out to the host VM. It's like, wait a minute, did I misunderstand you? No, regrettably, you did not misunderstand me. Something called the Docker sock, where there's a socket made available into your container where you can talk back to the Docker engine. Of course, that allows you to, like, so I can just go do what I want? Yes, and in fact, you can go create a container for yourself that actually mounts the entire host file system into that container, and you can control it. It's like, that seems like a security problem? Yes, it is. And if you go to Hacker News, as recently as like 12 hours ago, the top story was like, hey, idiots, don't do this. Don't run your Docker containers with this Docker sock exposed. And we've seen a couple of things like this. The Docker sock is kind of the most extreme, but we've seen things like this, where people are becoming a little bit strung out, a little bit addicted on being able to SSH into their Docker host and manipulate the app that's running in your Docker container. And the second you are SSHing into your Docker host, you have confined yourself to a VM. You've shackled yourself to a VM. You cannot get out of there, because you cannot SSH into the control plane of Joyent. I'm sorry. I love you like a brother or a sister, but you can't. So when you do that, you can't actually run out of a VM. You can never run a container on the metal. Indeed, you can't even run multiple containers per VM. You can't even run one container per VM, rather. You will be in this mode forever, where you're managing Docker hosts in addition to managing Docker containers. Don't do this. And as we kind of take apart with people why they're doing this, and again, I mean, a lot of stuff just works, by the way. A disturbing amount of stuff just works. An astonishing amount of stuff just works. Because the value of Docker is that you can be upstack. So a bunch of stuff just works. But the stuff that usually doesn't, because it's trying to break out of that abstraction, break out of the container. And ironically, the Docker host comes to resemble a pet. And all of the arguments for, no, I need to be able to SSH into my Docker host. It's like, those are pet arguments. And remember, we're in the cattle world. Right? This is the very good line that what Docker containers allow us to do is to think not in terms of pets, VMs and machines that we name and we love and we so on, but cattle, things that we eat, I guess. No, but we're managing many of them. We're managing fleets of them. And this is a very powerful abstraction, but we can only realize that power when we eliminate this dependency that we have on the Docker host. So we've seen that a couple of times, and on some things we try to offer things that can allow us to get the best of both worlds, and in some cases we just say, like, no, actually you just can't do that because it's fundamentally unsafe. It's like, I need to be able to load this kernel module for my container. It's like, yeah, you're going to be in a VM for the rest of your life. Hello, IBM 1401. So in terms of the broader container landscape, because it's becoming clear that containers are the future. And there's lots of, whenever you see like the conferences all pop up, the container camps and the container summits and the container cons, the container this, container that. Containers are the future. There's a lot of there. The upstack ramifications are pretty profoundly unclear at this point. And the fact is that these things are all open source. So from my perspective, it means that it's very unlikely to be winner take all. Right now, there's kind of this disposition to think, who's going to be the winner? Is it going to be Docker or Kubernetes? Is it going to be Kubernetes or Mesos? Is it going to be OpenStack or Triton? Who's going to be the winner? And I think these things are all open source. All those things are open source. So I don't think there's going to be a winner. I think we are moving to, just like there's not a winner for languages, right? I mean, if you're old enough, you remember when Java was going to be the answer to everything? Oh, God. Thank God we're definitely not in that mode anymore. Java's great. It's a right tool for some jobs. But it's not the right tool for every job. And similarly, for these things, we're not going to have the right tool for every job. We're going to have productive mutation. For Triton's sake, we have deliberately taken a very modular approach, and we view the container as a general purpose foundation. We're not trying to make a prescriptive framework. So in terms of actually realizing the logical extreme of the container revolution, we do need, just to reemphasize, we've got to break this VM mindset. We know this in part because we've been down the container path for so long, again, way too long. I feel like Alexander's army. You know Alexander the Great? Alexander the Great took 106,000 men marching 26,000 miles in 323 BC. Just like, and I feel like that's kind of our container odyssey. We've been on this for like 106. We've been for 20-odd thousand miles. We've been doing this a long time. We've seen a lot of country, and in particular, we know that containers will revolutionize storage. So we've got something we've developed called the Manta Storage Service. We actually presented it here 2 years ago, now open source, that allows you to have an object store like S3, and when you want to actually perform computation on it, instead of dragging your objects out to EC2 or what have you, you spin up a container where the object lives, on the actual node that contains the object. You can log into your object. You're like, yes, you can log into your object. It's pretty mind-blowing, and it allows you, like, if you want to grep a petabyte of log files, why don't you use grep to do that, actually? It's a very good utility. But that's in the future still. I mean, it's there today, it's open source, you can use it and so on, but people are still understanding the full ramifications of the container revolution because we've got a whole group of folks that are new to this idea. We've been around it for a very long time, and we've seen what can happen, and we know that containers will actually change everything. So in terms of Docker and production, I'm hoping that the 0 hands that went up will almost certainly turn to at least 1 or 2 hands next year, probably a lot more actually, because you are almost certainly hearing things about the need to evaluate Docker, explore it, and maybe your hand doesn't go because Docker in production because you've managed to fight off the barbarian hordes. But at some point, you're going to need to very seriously consider Docker in production. And what I would want to leave you with is if your allergic reaction to Docker is around all of these tenancy and security issues, production issues, these are legitimate grievances, and I would say that don't blame Docker for those grievances. That those grievances come out of the fact that Docker's substrate has been is fundamentally limited. And you can actually have it all. Triton represents that belief. There will be other things. I don't think Triton will be the only one. There will be productive mutations, but you will be able to, in the future, immediate future, if you want to do it on Triton, be able to deploy containers safely in production. You get multi-tenant security, operational elasticity, and on-the-metal performance. Don't let anyone tell you have to choose, because you don't. And with that, thank you very much. So I got no idea what time it is, because I think I'm probably over. Do we need to go to lunch? I can take questions if people are interested. I've got just total shameless. If you're like me, I will do such dirty, despicable things to myself to get a free T-shirt. You don't have to do anything dirty and despicable. Just talk to Dave Pacheco and Patrick Mooney over there at Joyent if they can self-identify. It's like, wait a minute, did you just use me in the sentence of dirty and despicable? They've got a bunch of T-shirts if you're interested. And with that, happy to take questions, or I'll be around for today, tomorrow. So.